For over half a century, Homo habilis was defined by scattered cranial fragments and a handful of teeth, leaving its true place in human evolution uncertain. Early finds suggested a tool-using, large-brained ancestor, yet in the 1980s, limb data exposed unexpectedly chimp-like proportions, fracturing consensus and fueling debate. Was Homo habilis truly Homo, or just a clever australopith? Now a new partial skeleton from Lake Turkana, notably including both humeri, ulnae, and portions of the pelvis, delivers the most complete postcranial evidence yet, dated to over 2 million years ago. Its mosaic of australopith-like forelimbs and derived pelvic traits forces a revision of what we thought we knew. But what newfound answers and missing elements still keep the Homo habilis timeline open to question? Homo habilis remains one of the least understood members of our lineage, known mostly from isolated cranial and dental fragments dated between 2.4 and 1.65 million years ago. Nearly all diagnostic material comes from Olduvai Gorge and Cubiphora, yet the majority of finds are partial jaws, teeth, or small pieces of skull. Postcranial elements, bones below the head, are exceedingly rare and almost never found with matching dental remains, making it difficult to link body form to species with confidence. This scarcity has left major questions unresolved. Did Homo habilis possess a human-like body, or did it retain the limb proportions and locomotor patterns of australopiths? The incomplete record has forced researchers to rely on indirect comparisons and regression models, with estimates for stature and body mass varying widely depending on which fragmentary bones and reference species are used. Without more complete skeletons, interpretations of Homo habilis anatomy, movement, and evolutionary relationships have remained provisional and highly contested. In November 1960, Jonathan Leakey recovered the partial skull, lower jaw, and hand bones known as Olduvai hominid 7 from bed 1 at Olduvai Gorge. The specimen, dating to approximately 1.8 million years ago, was described in detail by Louis Leakey, Philip Tobias, and John Napier in 1964, who introduced the name Homo habilis, meaning handyman, to reflect its association with Oldowan stone tools. The team emphasized cranial capacity as the primary criterion for Homo status, with OH7's estimated brain volume of 680 cubic centimeters exceeding that of any known australopith. The hand bones, though fragmentary, suggested a precision grip, supporting the argument for advanced manipulative abilities. This fossil became the holotype for Homo habilis, anchoring the species and genus assignment in the scientific literature. The 1964 publication formalized the placement of Homo habilis within our own genus, setting a precedent for using brain size and tool association as defining traits, despite the absence of a complete skeleton. In 1986, Tim White's excavation at Olduvai Gorge produced OH62, a partial skeleton that challenged assumptions about Homo habilis. For the first time, enough limb bones were recovered to estimate body proportions. The results were unexpected. The forearm to thigh ratio fell squarely within the range of chimpanzees, not modern humans. Calculations showed a brachial index and humerofemoral proportions far more primitive than anticipated for early Homo. Depending on which comparative model was used, stature estimates for OH62 ranged from just 100 centimeters, with australopith-like scaling, to a possible 148 centimeters, if more human-like ratios were assumed. The upper limbs, especially, were disproportionately long and robust, with thick cortical bone. These findings contradicted the expectation of a fully human-like postcranial anatomy and forced paleoanthropologists to reconsider the evolutionary status of Homo habilis. With only fragmentary evidence, the debate intensified over whether these ape-like ratios reflected the true nature of the species or simply the limitations of an incomplete fossil record. KNM-ER 64061 stands out as the most complete Homo habilis postcranial skeleton yet recovered. Excavated in 2012 by Meave Leakey's team near Illiret on the northeast margin of Lake Turkana, the specimen derives from the Upper Burgi member of the Cubiphora Formation, securely dated between 2.02 and 2.06 million years ago. The inventory includes both clavicles, fragments of both scapulae, complete right and left humeri, radii and ulnae, partial ossa coxae, a portion of the sacrum, vertebral and rib fragments, and a proximal femoral shaft segment. This array of elements surpasses the completeness of OH62 and KNM-ER 3735, the only other partial skeletons attributed to Homo habilis, both of which are more fragmentary and lack critical anatomical regions. The preservation of paired upper limb bones, both arms from shoulder to wrist, enables direct assessment of bilateral symmetry and proportional indices, a rarity in early hominin fossils. The inclusion of both clavicles and scapular fragments allows detailed reconstruction of the shoulder girdle. while the pelvic fragments offer the first opportunity to examine ischial morphology in this species. The sacral and vertebral remains, though incomplete, contribute to estimates of spinal curvature and pelvic orientation. The associated lower dentition, catalogued as KNM-ER 64060, provides a secure taxonomic anchor. Crown dimensions, cusp patterns, in the presence of a 2-rooted fourth premolar closely match the OH7 holotype, supporting the attribution to Homo habilis. Geochemical, taphonomic, and stratigraphic analyses conducted between 2019 and 2024 confirm that the dental and postcranial remains derive from a single young adult individual. No evidence of mixing or intrusive elements has been reported. The specimen's age, just over 2 million years, places it among the earliest securely dated Homo habilis fossils. The completeness of KNM-ER 64061 transforms the analytical landscape. With both upper arms and forearms preserved, researchers can calculate brachial indices and examine cortical bone thickness directly, rather than relying on fragmentary analogs or regression models. The pelvic fragments, though partial, provide the first ischial data for the species, informing hypotheses about locomotor mechanics. The clavicles, rarely preserved in fossil hominins, constrain shoulder breadth and upper body posture. The sacrum and vertebral fragments support inferences about spinal alignment and trunk proportions. Together, these elements allow for integrated reconstructions of stature, body mass, and limb proportions, with unprecedented anatomical resolution for Homo habilis. The KNM-ER 64061 inventory enables direct comparison with Australopithecus, afarensis, Homo erectus, and other early Homo species across multiple skeletal regions. This completeness not only clarifies the anatomical mosaic present in Homo habilis, but also provides a robust foundation for testing evolutionary hypotheses about the origins of human-like body plans. The specimen's age and preservation make it a critical reference point for future discoveries and analyses. The absence of lower leg bones remains a limitation, but the available elements represent a step change in the fossil record, shifting the debate from speculation based on fragments to analysis grounded in a nearly half-complete skeleton. KNM-ER 64061's upper limbs provide the clearest anatomical evidence yet for the retention of primitive australopith-like features in Homo habilis. Both humeri and ulnae are preserved nearly in full, allowing for direct measurement of proportions and bone structure. The brachial index, which compares forearm to upper arm length, is notably high, closer to Australopithecus afarensis than to Homo erectus. This ratio indicates relatively long forearms, a trait associated with climbing and arboreal activity. The humeral shafts are slender with a weakly projecting lateral epicondyle, but the cortical bone is exceptionally thick throughout the upper limb. Such robusticity, observed in both the humerus and ulna, points to habitual loading patterns more consistent with powerful, repetitive use of the arms than with the more gracile upper limbs of later Homo. Ashley Hammond's decade-long analysis, published between 2014 and 2024, confirms that every major upper limb element in KNM-ER 64061 exhibits thick cortices and primitive proportions. The wide capitulum and narrow trochlea at the distal humerus, together with a large radial notch on the ulna, suggest a joint configuration that maximizes rotational capacity at the elbow. This would have allowed for extensive pronation and supination of the forearm, essential for both climbing and fine manipulation. The cortical thickness measured in cross-section rivals that of australopiths, indicating high resistance to bending and torsional stresses. Such bone structure is not typical of obligate terrestrial bipeds like Homo erectus, whose upper limbs are more gracile and less adapted for arboreal or force-intensive activity. Comparative analysis shows that the arm proportions in KNM-ER 64061 are not intermediate but distinctly primitive. The high brachial index and robust bone cross-sections contrast sharply with the derived, more human-like ratios of Homo erectus. The preservation of paired elements enables bilateral assessment, ruling out asymmetry or pathology as explanations for the observed proportions. Hammond's work draws on micro-computed tomography scans and three-dimensional reconstructions, documenting that the thick cortices persist along the entire shaft, not just at muscle attachment sites. This pattern is consistent with upper limbs subjected to regular, strenuous activity, possibly including climbing, tool manufacture, or carrying loads over short distances. The retention of these traits supports the interpretation of Homo habilis as a mosaic species, combining primitive upper limb adaptations with more derived features elsewhere in the skeleton. The evidence from KNM-ER 64061's arms underscores the persistence of australopith-like power and mobility in the shoulders and forearms, even as other anatomical regions began to shift toward the Homo pattern. This anatomical mosaic complicates any straightforward narrative of linear transformation from an arboreal ancestor to a terrestrial biped. Instead, it positions Homo habilis as a species balancing ancient and emerging adaptations within a single body plan. The detailed upper limb metrics, especially the high brachial index and thick cortices, anchor this interpretation, providing a robust foundation for future biomechanical and evolutionary analyses. Pelvic fragments from KNM-ER 64061 provide the first direct evidence of ischial morphology in Homo habilis. The preserved sections of the os coxae display a short, broad ischium with a relatively straight inferior border, lacking the pronounced curvature typical of australopiths such as Australopithecus afarensis. This geometry, combined with the partial sacrum and vertebral elements, indicates a pelvis configured for efficient bipedal locomotion. Unlike the long, posteriorly projecting ischium of australopiths, which facilitates powerful hip extension during climbing, the KNM-ER 64061 ischium is more similar to that of Homo erectus in modern humans, supporting upright walking and reduced reliance on arboreal movement. Stature estimation for KNM-ER 64061 relies on humeral length, given the absence of complete lower limbs. Regression-based models calibrated on early Homo and modern human samples yield a stature of approximately 160 centimeters. This places the individual above the size range reconstructed for OH62, estimated at 100 to 148 centimeters depending on scaling method, but below the mean for Homo erectus, exemplified by the KNM-WT 15,000 skeleton, which exceeds 170 centimeters. The calculated body mass, derived from humeral and pelvic scaling, falls between 30.7 and 32.7 kilograms. This is lighter than both OH62 and KNM-ER 3735 and significantly below the estimated 50 to 60 kilograms for Homo erectus individuals from the same region. The pelvic architecture and estimated body size together suggest a small-bodied hominin with a derived locomotor apparatus. The iliac blade orientation and ischial proportions imply a hip joint capable of stabilizing the trunk during upright walking, reducing energy expenditure compared to the more primitive configuration of australopiths. The partial sacrum, though incomplete, supports a lordotic spinal curve, further aligning the trunk above the pelvis and enhancing bipedal efficiency. These features contrast sharply with the upper limb anatomy, where KNM-ER 64061 retains a high brachial index and thick cortical bone, indicating significant upper body strength and possible climbing ability. Metric analysis of the pelvis fragments, conducted using three-dimensional reconstructions and comparative datasets, confirms that the ischial length to height ratio falls within the lower range for Homo erectus, but outside the australopith spectrum. The acetabular region, though partially preserved, is robust and laterally oriented, facilitating an abducted gait cycle. This configuration minimizes mediolateral trunk movement and is associated with the energetically economical walking pattern seen in later Homo. The combination of a Homo-like pelvis and primitive upper limb proportions in a small, lightweight body supports the interpretation of Homo habilis as a true anatomical mosaic. Scaling methods applied to the available elements produce consistent results: stature near 160 centimeters, mass just above 30 kilograms, and pelvic morphology closer to Homo than to any australopith. These findings resolve long-standing debates over the locomotor capabilities and body plan of Homo habilis, affirming that despite retaining primitive upper limb traits, the species had evolved a pelvis and trunk adapted for terrestrial bipedality. The absence of lower limb bones continues to limit full reconstruction, but the pelvic evidence from KNM-ER 64061 establishes a foundation for taxonomic resolution and future comparative studies. In 1999, Bernard Wood and Mark Collard reignited the genus debate by proposing that Homo habilis be reclassified as Australopithecus, citing its primitive limb proportions and lack of derived postcranial traits. Their argument drew on evidence from specimens like OH62 with upper limb anatomy that closely resembled australopiths rather than Homo erectus. Wood and Collard challenged the traditional emphasis on brain size and tool association, arguing that these criteria were insufficient for Homo status without corresponding postcranial adaptations. The proposal underscored the limitations of a fossil record dominated by cranial and dental fragments, with postcranial elements too incomplete for definitive genus placement. The ensuing controversy polarized the field, with some researchers defending habilis as a bridge between australopiths and Homo, while others saw it as an evolutionary side branch. The 1999 bid for reclassification left the status of Homo habilis in limbo, intensifying calls for more complete skeletons to resolve the dispute through direct anatomical evidence. Validation of the KNM-ER 64061 skeleton. as a single Homo habilis individual relied on a decade-long chain of analytical studies. In 2019, a comprehensive dental crown study matched the lower teeth to the OH7 holotype, confirming species-level attribution. By 2024, taphonomic and geochemical tests, led by Fred Grein and Elizabeth Present, excluded the possibility of mixing or intrusion, linking the postcranial and dental remains to one young adult. Bill Jungers, renowned for his expertise in hominin postcrania, guided the initial anatomical assessments, ensuring methodological rigor before his death during the project. The final synthesis, published January 13, 2026, in The Anatomical Record, provided the first unambiguous proof that both the upper and lower body elements derived from a single Homo habilis skeleton. This publication cemented the specimen's status as the most complete and securely attributed postcranial record for the species. Each analytical step reinforced the taxonomic resolution, closing decades of debate over fragmented evidence and setting a new benchmark for early Homo paleoecology. Between 2.2 and 1.8 million years ago, the East African landscape supported at least 4 distinct hominin species: Paranthropus boisei, Homo habilis, Homo rudolfensis, and early Homo erectus. Fossil evidence from Cuviphora in the Lake Turkana Basin confirms that these taxa overlapped both geographically and temporally. KNM-ER 64061, dated to just over 2 million years ago, demonstrates that Homo habilis persisted as Homo erectus was already present in the region. This contemporaneity undermines any simple linear progression from one species to the next. Instead, it points to parallel evolutionary experiments, with multiple hominins occupying overlapping ecological and temporal niches. The absence of clear ancestor and descendant sequences in this interval exposes significant gaps in reconstructing the emergence of human-like body plans and evolutionary relationships. Despite the breakthroughs offered by KNM-ER 64061, the absence of lower limb bones leaves critical anatomical and evolutionary questions unresolved. Without femora or tibiae, researchers cannot directly determine the humerofemoral index, leg length, or precise stature, forcing reliance on regression models with wide error margins. Targeted excavation at the original Illoret site, fine mesh screenwashing, and geochemical fingerprinting of isolated limb fragments are now central strategies for locating additional Homo habilis lower limb fossils. Securing these elements remains the top priority for clarifying locomotor adaptations, body proportions, and the evolutionary position of Homo habilis within the hominin lineage. KNM-ER 64061 forces paleoanthropology to confront a lineage defined by anatomical mosaics, not linear progress. Its australopith-like arm morphology, preserved in Cuviphora sediments, dated to 2.02 million years ago, confirms that multiple hominin body plans coexisted longer than previously modeled. Today, as genomic and fossil datasets expand, the search for human origins grows more complex, not less. Defining human remains an open, empirical question. The evidence, not tradition, will decide.